Hi folks, so James has asked me to work through exercise 7G question 6, which is asking us to resolve x to the power of 4 plus 1 all over x plus 2 squared into partial fractions. So the first thing I notice about this problem is that the degree on the numerator is higher than the degree on the denominator. So if I ever have situations where the degree of the numerator is higher, my first step is to divide the fraction and break it up into its parts. So this looks a little bit messy, and it is pretty messy. What I need to do is I need to divide x to the power of 4 plus 1 by the expanded version of that bottom line, which is x squared plus 4x plus 4. Now I can do this with long division, and I can also do it with synthetic division. I'm going to show you the long division way first because I think most of you have probably seen that more often in the past. And the first thing that we need to remember with long division and also synthetic division is we need to include placeholders for the other powered terms. So we need to have that plus 0x cubed plus 0x squared plus 0x plus 1. Okay, so let's work through the long division. The first thing I do is I say x to the power of 4 divided by x squared equals x squared, and then I multiply this by the whole expression, which gives me x to the power of 4 plus 4x cubed plus 4x squared. And then, like always, my next step is I'm going to subtract this from the top part. So the x to the power of 4's cancel out, so they should. 0 take away 4x cubed is negative 4x cubed. 0 take away 4x squared is negative 4x squared. And I'm going to bring down the plus 0x for the next part. Right, I don't need a 0 there. My next step in the long division is I'm going to look at this negative 4x cubed and I'm going to divide it by x squared. So negative 4x cubed divided by x squared is negative 4x. Multiply this by the expression again and I get negative 4x cubed minus 16x squared minus 16x, and I'll bring down the 1 in a moment as well. Not just yet though. Probably jumped ahead a little bit too quickly there. I first need to subtract these. So the first part will cancel out as always. If it doesn't cancel out, you've done something wrong. Then I've got minus 4x squared minus 16x squared becomes a positive 12x squared. And then 0 minus 16 will become positive 16x. Now I'm going to bring down my 1. So last step, I'm going to take 12x squared and I'm going to divide it by x squared, which gives me positive 12. And I need to multiply that positive 12 by the whole expression. And repeat the process, and isn't it long and wonderful? So I get 12x squared plus 48x plus 48, and I need to subtract these expressions. Hooray, we're finally getting somewhere. So the 12s cancel out. 16 take away 48 is minus 32x, and 1 minus 48 is minus 47. And this final term here now has, so I've got negative 32x. 32x is a smaller degree than x squared, so this is actually the end of the division. And this part here is my remainder. And the top part is my quotient. Okay, so what does that mean? It means that my expression up the top here can be equal to, so this expression here is exactly equal to x squared minus 4x plus 12, and then I still have negative 32x minus 42. Sorry, I don't know why I got 42 over there before. That should be a 47. Minus 47 still needs to be divided by x plus 2 all squared. And I'll write it in that factorised form again. Okay, have we resolved into partial fractions? Not completely. All we have done so far is divided to get rid of that higher degree on the top line. What we need to do now is we need to resolve this section into partial fractions. So let's just work with negative 32x minus 47 divided by x plus 2 squared. Let's work with that part there. Right, this case is the repeated linear factor case. So when I split this up into partial fractions, I'm going to have an a divided by x plus 2 squared plus b times x plus 2. And then how do I do partial fractions? Now that I've written it as its separated expression, I now work back to getting that common denominator. And to do that, I need to multiply both the top and the bottom line, the numerator and the denominator, by x plus 2 on that b term. Why do I do that? Because now my expression can be written as this. Okay, so now that I've got a common denominator on the right hand side of the equal sign, both of my denominators are the same, so I can ignore that part and I can just work with the numerator to find out values for a and b. And the way I do that is I can use simultaneous equations. I think someone suggested that in class, but I'm actually just going to say let x equal negative 2. Because if I stuck a negative 2 in there, the b term will cancel out and it will make my life a little bit easier. So when x equals negative 2, I get negative 32 times by negative 2 take 47 equals a. Quick calculation here, this becomes 64 take 47, which is 17. So my a value up here will equal 17. Now let's find my b value. Now I can do that by substituting in any value at all that I like for x, and in this case I'm going to substitute in negative 1, and my reason for putting negative 1 in here this time is because negative 1 plus 2 equals just 1. And that's kind of neat, I think, because it just helps me deal with some of these negatives a little bit easier. And I'll get that on the left-hand side of my equal sign, and I'll just have a plus b on the right-hand side of the equal sign. Tidy that up. We know that a is 17, and negative 32 take away 1 is positive 32. Positive 32 minus 47 is negative 15. Take away the 17 from both sides and we get negative 32. And that is my b value. So the minus 32, keep my colour coding going here, minus 32 x minus 47 all divided by x plus 2 squared is exactly the same as 17 over x plus 2 squared minus 32 over x plus 2. Add into that what I had at the beginning, which was, if I just go up a little bit, the x squared minus 4x plus 12 we can just stick that in the front, x squared minus 4x plus 12. And let's put it at the end on this one, x squared minus 4x plus 12. And we have resolved our original expression. There was our original expression. It's been resolved into partial fractions all the way down here. And it's quite a long, complicated expression. While we're here, let's quickly do this division using synthetic division. So what does that look like? So let's set that up. We've got x to the power of 4 plus 1, all divided by x squared plus 4x plus 4. So if I'm going to set this up with synthetic division, what I need to do is basically same thing as before. I need to put in my coefficients of the polynomial on the top. So that'll be 1x to the power of 4, 0x to the power of 3, 0x to the power of 2, 0x, and a constant of 1. Now when we've done synthetic division before, we've put a single value over on this side of the expression. When I'm dividing by a quadratic, I need to put two values. I need to put the opposite of the 4 and the opposite of this 4 as well. So I'm going to actually put a negative 4 and a negative 4 here. So this one represents the x term, this one represents the constant. Okay, just going to get rid of those x's because we don't actually need them. So what does it look like when I do synthetic division? Well, the first step, still the same, bring down the 1. My second step, still the same, I'm going to multiply that negative 4 by the 1 and write my answer in here. And then I'm going to multiply the second negative 4 by the negative 1, and it goes into the next terms space. Right, add those two together and I get negative 4. Now we're going to repeat. So get rid of those arrows. This time I'm going to do negative 4 times negative 4, which is equal to positive 16, and negative 4 times negative 4, which equals positive 16. I can add these three together to get 12 and repeat. So now negative 4 times 12 is negative 48, and then negative 4 times 12, which equals negative 48 again. Add those three together. Wow, that's an amazing squiggly bracket there. And I get negative 32. Add these two together and I get negative 47. Don't know why I wrote it there. Negative 47. And there is my synthetic division completed. So put all of that together. This is x squared, this is x, this is my constant, and then this part is my remainder, just as we had before. So it would become, this expression is equal to x squared minus 4x plus 12 plus negative 32x minus 47, all divided by x squared plus 4x plus 4. And we can keep going through the partial fractions process like we saw before. Okay, that's the end of the video.